There you go, man.
All right, thank you. All right. Well, thank you very much for the opportunity to be here. Kyle said, my name is Christian Solis. I work for McKim & Creed. We're a survey and engineering company based here in Raleigh. I've been working, I'm a certified photogrammetrist. I've been working in London for about 10 years. I've been working with unmanned systems for the last 5 years. So we're going to talk about a project that we did in Wrightsville Beach, Wilmington, North Carolina, in partnership with 3DR, which is a drone manufacturer, Esri, and in coordination with the Army Corps of Engineers and a few other groups. But before we do that, we're going to talk a little bit about basic photogrammetry. We covered a little bit of that, but we're going to add a little more about how we go through this process, and then we'll talk about that particular project. So real quick, just about McKim & Creed, we've been in business for 38 years. We have almost 400 employees. And our offices are spread mostly here on the East Coast. We have offices in Texas as well as I'm based at our Austin, Texas office. And in the 5 years that we've been working with unmanned systems, because we have so many surveys, our focus has always been small drones, big sensors. Because what's important to us, we provide data, we provide accurate information. So in the end, anything that we perform as a service, it has to do that function. It has to create actionable information that we can use. And that we can easily disperse with all of our surveying. One, it's to be another tool in surveying. That's what makes sense to us. That's how we're able to provide the service cost effectively. And in all our work, both with manned aircraft and unmanned systems, and one thing that I think is really important and we alluded to is that you have to have ground control to actually just place the data in place with RTK systems. But more importantly, you also have to have checkpoints. You need to be able to verify that what you're making is as accurate as you say. It's not good enough just to say it's accurate. We use an RTK system, therefore it's accurate. You need to be able to prove that. And that's with any other technology. We're doing LiDAR, traditional programming, it's the same thing. That's why we have accuracy standards that we can use for this. So just real quick, photogrammetry. This is the ASTRS definition of photogrammetry. Like I said, I'm an ASTRS certified photogrammetrist. There are LiDAR drones, but 99% of all the mapping that we're doing is photogrammetry. LiDAR will get there. I've been working with LiDAR for 10 years. But right now, there's a cost barrier. It just doesn't make sense. So some of the pros and cons of the photogrammetry approach, the contact-free sensing, or we don't have to actually touch the ground like a traditional survey. We can cover large areas. We've created, with new algorithms, we create these 3D point clouds. And we're able to revisit things often. Some of the cons of this approach is that it's passive sensors, so we're recording like an assist camera versus LiDAR where we're creating one like course. There's occlusions and visibility constraints, especially vegetation. So there's only certain sites where this tool makes a lot of sense. Because you're triangulating location, you can't see all vegetation. That's the physical constraint that exists in photogrammetry. So where you deploy this tool is important. So real quick about the arrow triangulation process. This is photogrammetry. This is what we do. And all the software that you use for photogrammetry, is Pix4D, PhotoScan, or anything else, it's doing the same process. It's doing this right here. So the first thing we do, obviously after flight, and we're flying a whole bunch of images in overlap, right? So traditional photogrammetry, the manned system, the metric camera, are usually flying 60% forward overlap, the images down the flight line, and 30% side lap, flight line to flight line. And with metric cameras, there's a lot of things that we know already. So we're able to do that. With unmanned systems, we're dealing with a lot more unknown variables. We don't know the exact position of our camera. We don't know the orientation of our camera. We don't know specifically the distortion parameters of our camera. We have to solve all those things. And what we're using to solve them is our ground control. That's our known that we use to solve all our other unknowns. So we have our ground control. I don't know if you can see all those little knots. So disperse our ground control evenly throughout the site. And we measure that in. Once we've done our initial tie point, think of weaving the rug together. We've done this kind of loose weave where we found commonality in all these images. We kind of based on the initial information that we have. Then we measure the ground control. And once we have the ground control in, we can do what's called unload adjustment. This is what all the software is doing. Because we're solving all those unknowns all at once. We're figuring out exactly where the camera is based on the ground control, the orientation, and all the different disposal parameters. And once we do that, we're able to do what I call incident management. Some people call it structure from motion, and a lot of people call it FODAR. Please don't call it FODAR. But what you're looking at right there, that's a point cloud. That's not a 3D point cloud. So we've created XYZ locations, perfect. So if you have a 3 centimeter ground sample distance, you're creating an XYZ location every 3 centimeters. I mean, imagine doing a traditional survey and getting that type of density. Quite remarkable. So once we have our density matching, and this is just kind of an example of the site of what a 3D point cloud is. It goes really fast, a little nauseating, but this is kind of just showing, taking 2D information and making 3D information. We can do our ortho rectification process, which is a traditional photometric process. So we create a surface from our density matching. We need some kind of rasterized surface. So with ortho rectification, what we're doing is we're correcting in an XY 2D space positioning of everything. So if you think of looking straight down on a hill, and there's a tree on the hill, or a house on the hill, and there's a house in the valley. And we know those houses are the same size, but in a picture, they're going to show up as different sizes. So we need to correct for that. So we use the surface information, our newly found locations of the camera, and the information about the camera. And we're able to ortho rectify those individual images. So we can stretch the house in the valley and shrink the one on top of the hill so that we can spatially measure things off of it correctly. So once we have all those individual images, we need to seam them together into one cohesive image. And that's when we do our seam line extraction. We find the proper place to cut all those images so we can put them together into one image. After that, we do our radiometric and geometric corrections if need be. Sometimes areas will be lighter or darker. We need to correct for those things. Or you have areas where you're at half a semi-truck on a highway, so we need to correct for those things. And once that's complete, we're able to create a final local production. So that's the process. That's the process of using any photogrammetry software. That's what you're doing. So the project we're talking about is the Rice to Beach proof of concept we did with Esri. We did this under 323. So actually, we didn't fly this under 107. It was actually a 223 project. And at the time, we were talking to Esri, and they were getting ready to launch a product called Drone to Map. And they were looking for a particular use case that they could do. And they had some interest from the Army Corps of Engineers. So they said, well, we have an office in Wilmington. We can set something up. If there's a particular site the Wilmington Army Corps is interested in, I said, yeah, we want to measure volume on Rice Beach, and we want to see how accurate this tool is to assess the pre- and post-storm damage so that we can quickly correct any damage that's done. We also already had a relationship with 3D Robotics. And they were getting ready to launch this product right here, which is called SiteScan, which is a bigger camera on an existing consumer drone. And that's something that we had worked on. We actually built a prototype before this came out with a Sony QX1 camera, working with their API to trigger that. We were looking at, like I said, to put big sensors on small drones. We wanted something that's somewhat disposable. We need to keep the cost down for the client. So, first site, the Rice Beach site, we flew from the Oceanic Pier to Mason Borough Inlet to the south. We did that coordination with the city of Riceville. We did that coordination with the Riceville Beach Police Department, so we cordoned off this area during the flight. We laid out 14 control points. So we used these ceramic tiles that were painted like that so we could easily identify them. And then we also collected a bunch of checkpoints. So this was 2 flights with that camera system, our 10C, APS-C sensors, and we had a ground sample distance about 1.2 meters. So in Drone to Map, it took about 4.5 hours to process all this. We were done. We created a work on mosaic, digital DSN, point cloud, and 3D mesh. This is a picture of the checkpoint, or control point layout, control line checkpoint layout. You should you can see they rebuilt a lot of the beach that image was taken. But we have 14 control points, 22 blind check shots to verify the data. And we also flew a couple other systems, just because we wanted to test a few things. We flew a site scan system, we also flew a solo with a GoPro camera, and a DJI Phantom 4, which is just a release. I should say the Phantom 4, you can see right here, we actually flew it lower. We wanted to, as close as we could, match the ground sampling distance as we did with the RTC. The GoPro setup, we do not mapping system, we just put it 400 feet. So when we look at verifying this information, we look at it the same way we would any kind of geospatial information. If it was LiDAR, we're creating a point cloud, so we want to treat the point cloud piece like it was LiDAR. We're creating ortho. We want to treat that just like we would a traditional ortho phone with a metric camera system. So for the point cloud portion, the elevation information, we take that into some of the LiDAR tools that we use. In this example, we're using LP360. I don't know if anyone uses LP360, but if you're dealing with point clouds in our, this is an excellent tool. I really recommend it. It has a tool that we can use to create an RMSE, or a control report on the accuracy of our data. So looking at just the blind shots, the shots used to verify the actual accuracy, these are the results of the 3D flights. So this is really small, but I want to point out, so the vertical error rate, this is how high and low we're missing the shots. So you can see with the Phantom 4, we're missing the shots by 0.8 feet and 1.4 feet. Really, really bad. Because we would not want to work on a product like that. So we're looking at our total RMSE from that, and we're at 0.5 feet. But based on our NSSDA calculation for our contour interval, that product's only suitable to produce 200 that. So even though we're flying with a similar ground sampling distance as RTC, you can see the accuracy is pretty similar. If you look at the GoPro, kind of similar. We're off by 0.5 feet in 1700s in the other direction. RMSE is low, not presets. The sight scan system, you can see our outliers are around 2500s and 1900s. Our vertical RMSE is around 1300s. And our NSSD contour interval is 0.42. So even though we have similar ground sampling distance, you can see that the RTC system was much better. And we kind of wanted to explore that and figure out why there was such a difference. Because the imagery from the Phantom 4 is fantastic, but there's certain big characteristics of it that the photogrammetrists we look at, and no, they're not perfect for that. So you can see this is a distortion plot for the 3 different camera systems, starting with the GoPro, kind of what you expect. It's a wide-angle fisheye lens. You'd expect a lot of distortion. The R10C, you can see there's not a lot of prime movements. The Phantom 4, interestingly enough, had all the distortion pushed to one side. At the time, we weren't quite sure. We talked to a lot of folks. We had other people that were flying these systems, and the best that we could come up with at the time is that that particular model, the Phantom 4, the original Phantom 4, had digital image stabilization. So electronically, it's doing certain things that make the image quality better, but for photometric purposes, creates problems. But I will say the new Phantom 4 Pro does not have this problem. It has mechanical shutters and other things that correct the problem. So, because we were working in conjunction with the Army Corps of Engineers, they were actually going to map the beach that day anyway with a terrestrial scanner. So we were able to compare those 2 data sets. So not only we had our blind shots ready, but now we have another data set that we can compare to, something that's well established, we've used for many years to compare it to. So the first thing we did is run the same control report. You can see our MSC, 1300s. Terrestrial data had the same accuracy, and the outliers were about the same. So 200s on one side, or excuse me, 2 cents on one side, 200s on the other. And their contour interval was almost at 0.43.
This is the same 23 tracking.
What's that?
This is the same.
Yes. Exact same data.
This is just terrestrial.
Just terrestrial. And then what you're looking at right here on the right side is a normalized surface. So we have these 2 surfaces now. We know what they look like relative to the ground control. We want to compare them to each other to see how well they hit each other. So basically we take one surface and we subtract the other surface from the other, and we report the difference. And in this instance, we just made two different colors. So anything that's green is better than 3/10. The reason we set that so high, I should point out, is that our vertical error mean, the average and this, was about the same too, except it's in opposite directions. So, you know, with data we talk plus or minus. This is that, where one data was plus, the vertical error mean, the other one was minus. So it's kind of worst case scenario. So that's something to think of when you talk about plus or minus. You're comparing two mean sets. Also, where it's purple, we weren't able to fly the drone during the low tide because of coordination with the police and the timing and allowing people back on the beach. They were able to do terrestrial during the tide. So all this area on the edge is purple. The reason for that is because they were able to capture more data in the water than we were. See, by and large, most areas hit really well relative to each other. Little areas, a few areas here and there. There's a lot of vegetation right here where things are not. The other thing is Hanover County gave us beach profiles that were done a couple weeks before that, so some more traditional survey. And you can see those profile lines that were done up there. So they're done 1,000-foot cross section, points every 2 feet. Unfortunately, there's too many ground control points to actually run through LP 360, but looking at profile, you see these little red squares, those represent those profiles, and you can see they match quite well. So it's kind of a business comparison of what it would take to do this entire area of traditional survey. The UAS is about 30% cheaper, so we as a UAS crew, but we're able to do it quicker and at a cost savings. The terrestrial data, this is about 50% cheaper than the terrestrial data, and aerial LiDAR was about 60% cheaper. The main reason for that is when you do aerial LiDAR, your biggest expense is mobilization, just getting that to there. Now, aerial LiDAR, traditional manned aerial LiDAR is a lot cheaper the bigger the site. The next site was the Eagle Island disposal site. This is on the Cape Fear River, an area where they dredge material and they put it in there. So we did part of 2 cells, covered about 106 acres, 2 flights. We used 7 points, ground control targets, which we placed around the edges right here. We didn't actually go inside the disposal site. Similar to ground sampling distance for the whole area, and we didn't collect any checkpoints on this site. This is an example of that ground sampling distance right there. That's the inside of the pond. And the reason this tool is really useful for this, we talked about using drones for jobs that goal during the dangerous. And this is all of those things. So these disposal sites, they're putting dredged material inside of it. And it's hard on the outside, but it's quicksand underneath that. And being inside that is a very dangerous place to be. And this is how they traditionally survey this. In fact, when they survey this, they take 4x8 sheets of plywood and lay it out. They stand on those to increase their footprint. And they start to do the profile shot. And then they take another piece and put it in front of it. Hopscotch those pieces. You can imagine how long it takes to survey an area like that. We knew the site had been surveyed traditionally earlier that year, prior to the dredging season, and we created a surface from that. It took about 2 weeks to cover that cell, and we did 2 flights. We could have covered that whole site in 2 hours. We're going in a small section. What's that? Sorry. And we're able to compare those 2 things. So this is some examples of some areas where there's error from the traditional survey. Looking at those same areas from the UAS data, obviously it's a lot denser in those areas, and those errors don't exist. So this is a profile of those different shots compared to each other. You can see all those red dots where the traditional survey surface, and you can see the ones across the middle of the pond. Those are the ones they had to hopscotch. We didn't have to set foot in there. And this is just a profile right here of the 2 shots. So you can see right here where they're different inside the pond, and that's because the survey was done before the dredging. We did it afterwards. So again, like we normalized the surface on the beach, we did the same thing with these 2 data sets. And those errors we pointed out earlier, you can see them right here in that normalized surface. Now the areas in green right here, When we compare these two surfaces, you measure that difference right there on the actual berms. That difference is between 1/10 of a foot and 2/100ths. So again, kind of just doing the cost analysis is about 80% cheaper than doing it traditionally. And again, that's because the site is so dangerous. We don't have to step foot in there. And then the site was a little bit smaller, or a little bit larger, excuse me. So the aerial lidar cost was a little lower. And just real quick about this project, I mean, you do a lot of projects, but it's rare you get to do projects where you have all these different variables to compare to, this type of analysis, and there's many people involved. Like I said, we had the City of Wrightsville Beach Police Department, UNC Wilmington, several Army Corps districts. We had people come up from the Mobile district, the Jacksonville district, and a couple others. And we had the Audubon Society that was there to monitor the birds, which was kind of interesting. So they sat where the birds were nesting at the time and made sure the drone did not disturb them. And I'm happy to say that the birds could care less about the drone. We actually won a Grand Conceptor Award for Best Engineering Project in North Carolina for this particular project with Esri. And that's it. Thank you.
Thanks, Christian. So the goal for this session was to show real data, real applications, and hopefully apply it to directly and answer some of the questions that you've got and are either holding you back from getting into this world or just things that you've been wanting to know. So I'm going to turn it over to Rick Lusher now from Duncan Parnell. The goal for Rick now is to kind of help answer some of your other questions about where are things at, what does it take to get into this. Duncan Parnell does have their booth up on the show floor, and we started working with Rick 4 years ago.
Yeah, about 4 years ago.
And that's how we got our relationship with Trimble started. And so we've been flying our Trimble airplane for quite a while now. They gave us one about 2 years ago. And so that's a great resource. All of these guys on the panel are members of our consortium at NC State. So it was kind of an easy resource. But and I kind of build on where Christian was going there with one of the last slides about the community effort. North Carolina has done a really good job of building a community supporting this. As we've been trying to answer these questions, work with the regulators, work with the local communities, work with the industry partners to try and accelerate the adoption for UAS statewide, and that continues to grow. That's why we had the panel we had up last time to not only get the applications of this right, but make sure we get the regulations in place too. So Rick's going to help hopefully tie together some more questions, and then we'll go to Chris. It's all yours, man.
Thank you.
You got slides?
Yeah, I see.
Yeah.
How do I get out of here? There we go. There we go. I'm Rick Lusher. I'm with Duncan Parnell. Thanks, Kyle, for the introduction. I know a lot of you in the room. I work in the geospatial group with Duncan Parnell out of Morrisville, and we are a Trimble navigation dealer, Esri partner. We sell traditional land surveying, GIS mapping equipment out of our office in Morrisville. Today, I'm not going to really get into something too technical. It's more of a background of where the market and that type of thing is headed and how you can maybe get into this and some of the basic questions to answer and where things are going from here since it is such a big buzzword now. So where is the market headed? First question, is UAS a game changer? And what do I mean by game changer? A game changer, 20 years of doing this business, there are certain products that come along every so often that we call game changer, kind of just a marketing term or a buzzword. And, you think of dual frequency GPS, on the land survey side, robotic total stations, the EDM, the real-time networks. I had to mention that one since Gary was in the room. Things that kind of take the market by storm, increase productivity, make you more efficient at your job, and change the way that you collect data. And certainly UAS is a game changer in that arena. We field more questions probably about UAS now than we are anything else in the market as some of the other products mature. So is UAS, is it something that will be to the masses? Yes, it will. It's coming, it's here. You can see some of the examples of how that they've used it in different applications from engineering, and then you'll hear Chris talk about some of the other applications outside of that world. It will be brought to the masses. When you start hearing companies like Amazon talk about getting into the UAS business, then it's coming to your arena. It will change the way that you collect data. It'll change the way we do business and everyone in this room. So it certainly is going to be a product to the masses because that's a relatively, I won't say low barrier to entry, but the cost is low. There's price points all the way from a few $1,000s on up to something like a UX5 they mentioned that are at the high end where you can spend $30,000 plus. But with the relaxing of the, I won't say relaxing, but the changing of the FAA rules with Section 107 and that type of thing, certainly the barrier to entry is a lot lower now. What we see in the marketplace is, and I'll hop over here so maybe I'm blocking people, but there are strategic partners among manufacturers and across software platforms. Companies like Trimble and Esri are partnering. I heard, I think Christian mentioned the software with Esri that they've partnered up with. You see Pix4D, Trimble's purchased Info where they came up with UAS Master. There's partnerships with Trimble and Dell Air Tech and Microdrone. So you're going to see some of the manufacturers and software to where they become universal that you can accept across different platforms because there are so many what we call UAS platforms on the market, literally hundreds if not thousands. So what is UAS? An unmanned aerial vehicle, UAV, commonly known as a drone. Sometimes we don't like to use that word drone because it has some different connotations, but is an aircraft without a human pilot on board. The term UAS or unmanned aircraft system emphasizes the importance of other elements. It's not just the nice helicopter rotary wing or the fixed wing aircraft that you see. It includes the control system, the ground control station, the control link, which is a data link. You've got to have communication to control the device, and other related support equipment. That might be where you bring in your GPS to set ground control and that type of thing, or a launcher to launch the UAS. So some UAS basics. Where is the UAS industry now? It's currently in an incredible growth phase. It's going up, 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 up. As I mentioned, when you hear companies like UAS or Amazon and other companies, you see companies like Christian's, McKim & Creed, and everyday applications that's starting to get into government. North Carolina Geodetic using it for disaster management, that type of thing, is an incredibly growing industry. There are many companies offering many solutions. Our first quote-unquote drone we bought was a few years ago, and a guy built it in a garage for us in Charleston, South Carolina. And that'll be part of my next thing is beware of low-value offerings. It wasn't really a low-cost item, but it was an early entry. We got into it before Trimble was kind of in the game. And we learned some lessons there along the way, and now we have it sitting there. So just be aware of that. Be aware of where your support and your service and who's going to back up that product and does it flow into your software platforms. Some things to consider. Image quality is a combination of sensor size and megapixels. When you get into the UAS business, you got to think about things like quality of the gimbal, which holds the camera. You got to think of what type of camera you use, and again, sensor size and megapixels. Choose survey-grade components if you want consistency in both vertical and horizontal. Look at the system as a whole versus just hardware and software. There's a lot of software platforms out there. There are literally hundreds, probably thousands of UAS manufacturers. I think one of our guys set one down one time and did some research over the weekend. He was bored or something and came up with 400 different manufacturers of drones. Fixed wing solutions. You saw examples of both. Kurt went over the fixed wing solution. It's made the collect data in wider areas at higher altitudes. Requires FAA airspace clearances. I won't get into too much of the regulations with our time here, but it's much more efficient than full-scale aerials. Rotary wing solutions, we probably field more calls about the rotary wing solution just because of the cost and the ease of launching that type of device. It can more altitudes, smaller areas, higher resolutions, used for monitoring videos, photos, inspection, asset management, that type of thing. So UAS aerial imaging is emerging technology. It's well suited for geospatial professionals. I'm sure you're all, if you're not into it now, you will be as the market heads that way. I won't say that it's to replace everything you're doing and replace some of the products we're selling. I think it's a complement to that toolbox. It's a lower barrier to entry and potential mass adoption. Because of the cost, the competition amongst the manufacturers is keeping the cost down. The technology's becoming more mature. The software companies are becoming more receptive to taking data from different sensors. So there's a low barrier to entry now. Things like Section 107, the FAA process, and Kyle and Gary could probably test this, is a lot easier to go through now. When we first started, it was a very lengthy legal process, but there's much lower barrier to entry now. Some of the target markets and applications you can see here are everything from public agencies to engineering and surveying to natural resources across the board, everything from boundary surveying to as-built surveys to volume calculations, everything for vegetation and health. We've seen some of the examples today with public agencies for disaster analysis. That was a good example that NC Geodetic had there. Everything from environmental and landfill applications across the board. So this tool is something that can be used across a lot of different platforms, a lot of different agencies, and certainly would be something that you need to look into as the process improves. 5 key benefits, as we kind of summarize here. It's safe. It enables remote measurement of ruggedized, hazardous, hard to reach, or unhealthy areas without risking injury or worse to people. So if you have an intersection that's a busy intersection, and you can get it shut down with the police, as he mentioned in his example, then it's safe. You don't have to put someone out in traffic. It's efficient. You can ability to capture data and generate deliverables with more detail and faster, achievable with terrestrial measurement. Again, not to replace our GPS products. We certainly don't want to see those go away, but certainly in a mass deployment type situation or a quick time frame, it is much faster. It's versatile. It can serve a lot of professional markets and applications. It's very economic as compared to other devices and software platforms. The cost now is somewhat relative and inexpensive. Low cost to purchase, and it was once we saw it when it first came out, it was really something that was for specialized surveying and engineering firms, but now certainly for the GIS professional and a lot of public agencies and that type of thing, the cost has come much down. So I think you're going to see a lot of changes, a lot of strategic partnerships in our industry between companies that manufacture traditional surveying and GPS equipment and software platforms and the hardware platforms on the UAS side. So thank you very much, and I'll turn it over.
Thanks, Rick. That's there's several really good points in there, and we're going to team all up. Thanks. We open up for questions. Especially as we talk about the technology evolution and the pace of change within this industry over the last couple of years. It's continuing to speed up. Chris will talk about this here in a minute from when he got into this way back in the day before he had that beard and to where we're at today. And with where things are going, work with the industry partners that we've got. So lots of change, lots of cool stuff going on. So Chris, I'll let you kind of give the responsible, if how to own a pet, how to own a drone. So it's all yours, man.
All right, so I'm Chris Keon. I'm the owner of Synergistic Solutions International. Under SSI, we actually have three companies. We have SSI proper, which we do our services, training, applications as far as that nature. We have SSI Unmanned, which we are a worldwide enterprise solutions dealer for DJI. So we sell the full line of DJI products. And then we have SSI Maritime, which we do maritime work with ROVs, underwater ROVs. But we've actually started jumping into the aerial work with that as well, doing bridge inspections, dam inspections, so we can cover both air and underwater with that. So I started out in the UAS community in the DoD world. So in 2006, like you said, I was nice, clean shaven, had no beard, had a high and tight haircut at Fort Bragg, North Carolina. And they trained me how to fly a fixed-wing aircraft that was 4.4 pounds, had no weapons on it, and we just went out and did surveillance. That was called the Raven. It was made by AeroVironment. It's a fun little aircraft to fly. So then they sent me to the wonderful country of Afghanistan, and I got to go fly over there. We did everything from site surveys, and actually it was, looking back at it now, I didn't realize what I was getting myself into, is moving into the commercial industry. But I did a dam survey over there. So in the province that I lived in, they had a really rough winter, and when the snow started melting, started coming out of the Hindu Kush, started flooding the lake, and they said, hey, you think we can use this system to go and look at the dam? I was like, sure. I mean, I'm just some dumb sergeant that flies this thing. Let's go check it out. So they tasked me out to a special operations group, and we went to go fly the dam. And now looking back at that, it's like, wow, that was 10 years ago, 11 years ago. So now looking at what we're doing. So after I got out of the military, I went to work for AeroVironment as a contractor, training the military, government agencies, foreign militaries, three-letter agencies how to fly systems. And those were specifically the AeroVironment family of systems. Now they had a quadcopter called the Cube, other fixed-wing aircraft with Raven, Puma, so we had anywhere from a 4.5-pound fixed-wing hand-launched throwable aircraft to a 15-pound hand-launched 110-inch wingspan aircraft. So to give you that idea, we went from flying anywhere from 60 to 90 minutes at 10 kilometers away to flying 3.5 hours to 60 to 70 kilometers away with the larger system. I'm still a contractor for them. I still do some independent stuff and teaching. But now obviously going into this side, on the commercial side. I've been partnered with Kyle now with the NGAT Center since, 2012-ish, 13? 13. Called him up while I was still a contractor, traveling out, looking online one day, got bored, saw that NC State was doing this stuff. I called him up and said, hey, is this actually going to happen? Didn't tell him who it was, nothing. Is this going to happen? He goes, well, I hope so. Who are you? What do you do? And we've had a really nice partnership since then. So, if you're looking at getting into a drone, the biggest thing, and some of these guys have covered it, what to look for, what to buy, all right? What not to do. I just left a conference earlier today. First, do your research. I don't care if it's a DJI system, if it's a 3DR system, if it's some off-brand, right? You're going to get what you pay for, okay? We had one guy that pulled out a little $60 drone and it actually had a camera on it. And he says, well, I've got a drone. It's got a camera. I says, what does it do? And he says, well, I paid $60 for it. I says, don't fly it. He says, why not? I says, well, it doesn't have GPS. It doesn't have this. It doesn't have that. And he was like, well, I just wanted to learn. And I said, well, you spent $60. It's going to fly for about 2 minutes. It's going to take you 2 hours to charge it. You're going to have to trim it out again. I said, why don't you go and spend something, spend a little bit more money, invest. This is about a $1,300 system, right? But it has 2 GPS modules on it. It has vision positioning. It has obstacle avoidance. It's a quad, right? I said, so do your research. Also, what else do you need to look at? The licensing. We talked about 107, right? There are companies out there right now that are advertising that they're FAA certified to train you how to fly, to get your Part 107. I'm going to tell you right now, that does not exist. There is no such thing as an FAA Part 107 certified course. There's not, okay? The FAA has not certified anybody to teach that course. There are courses out there that are very good, but if somebody tries to lie to you and says it's FAA certified, it does not exist. Do your homework, study, and you can go and take your 107 certification. It's a 60-question test, costs about $150. Now you can operate commercially. But it's not just go get my license and go fly. What else do you need to have? As a commercial company, one of the things that we've found is going out and working with different vendors is, what do they require? Insurance. So insurance not required by FAA, but these vendors, these county emergency response agencies, sheriff's departments, things like that, do require you to have insurance. So we carry $1 million of insurance on every one of our drones. I hate that word, but that's what everybody knows them as. And we have whole replacement values as well. We also, within my company with SSI, we're held to a standard. So if you come out to one of our sites and one of my personnel is flying, you could say, I'd like to see your folder. In that folder, we have a copy of the North Carolina driver's license, a copy of the Part 107 certification, their hard card. We have a copy of the North Carolina permit. We have their flight hours that they've been flying. We have a copy of our certificate of waiver of authorizations. For instance, we just got one for Fayetteville to fly in Class C airspace. They're logging all their flight times. We have the state regulations. We have the federal regulations, all within that folder. So if one of my people hands you their folder, here it is. It's all in one folder that you can see. So there's just a lot of things that you want to do. Standardization. I know we had talked last week on the phone about standardizations. Currently, there's no regulations on that. We're trying to write it as an industry standard, so some of us has talked about that. And what is that? So standardization would be, are you proficient? So if somebody in here, any pilots, like private pilots, commercial pilots, anything like that? Okay, so as a private pilot or a commercial pilot, you have to have currency of an aircraft, right? You have to have so many flight hours per quarter. Every couple of years, you have to have another test, right? You have to do check rides. In the commercial UAS industry, there's no standard for that yet. We wrote it within our own company. We're trying to push that out to other agencies. So basically, we would do an annual, a semi-annual, and a no-notice evaluation. I will show up on site with one of my people and say, all right, hand me your book. I want you to show me pre-flight, post-flight, during your flight operations, emergency procedures. I want you to show basic operator-level maintenance, right? If you're going to hire an operator, okay, a vendor, right? So let's say, one of these guys comes out and says, hey, Chris, I need you to go and fly this, right? They need to vet me, right? How do they know that I know what I'm doing and I'm not just some kid? And I like the way that Kyle put this before a couple years back. He says, yeah, these guys didn't know how to spell UAS a year ago, but now all of a sudden they're drone experts because they got a 107 license. I have had customers call me that went and got their 107 license, and they call me up and they say, hey, I've never flown a drone. What's the best one to get? What's the easiest to fly? And I'm like, oh no. This is the community that we're dealing with. Because it's very easy to go do it. But you want to be able to vet your client or your vendor that's providing that to you. Check the references. Ask for insurance. They have it. I'll tell you right now, insurance on UAS is expensive. Right? So if somebody has taken the time to go and get that insurance, they're serious about this. They're not joking. They're doing this for real. They're flying a lot. Ask them, what situations they've flown in. When's the last time that they flew? What aircraft are they flying? If somebody shows up and they say, hey, I got this little guy right here with a camera that I got at Best Buy. Probably not what you want to be dealing with. All right. The other thing, when you're getting into UAS, any of these gentlemen up here will tell you, I tell people all the time, if you're looking at buying a UAS, do two things. One, open your wallet. Once you get into it, you're going to want the next best camera. You're going to want the next best aircraft. It's addicting. It's a lot of fun. The other thing is if you do not do proper maintenance on these systems, they're going to fail, right? So you can't just set it down and leave it for 6 months and expect it to work the exact same way. There's firmware updates. There's maintenance that you have to do. You got to feed it, right? You got to feed it with time, give it some love, right? You made the comparison, own a dog, own a drone. So that's what you got to do. You got to go out and spend time on it. You can't buy one, get your license, go fly this month, not fly for 6 months, and expect to be proficient. It's a perishable skill. So I've talked a lot. I know I'm going to open it up to questions for all of us with Kyle. So anybody's got any questions, go ahead and start.
Yeah, that's perfect, Chris. I appreciate that. So everybody's fair game. We also have Gary Thompson from Emergency Management. So are there any burning questions, or do I get to start opening up and asking these guys tougher questions? What do you guys have? What have we not covered? Have we tried to cover everything from real data, real imagery, real applications down through a little bit on the regulation side? What does it take to own it? What does it take to get access? How are we using it in the state? Anything else? Drinks aren't out yet. We might as well sit here and keep talking. Reception hadn't started. All right, I will warm things up then, and all 5 of you get to answer this one. Since Gary, you are here. Whoever's got the mic gets to answer first. What is one recommendation if you're going to start get into the drone world? What is the one thing you would start with? One recommendation you would tell somebody to think about first?
Christian just mentioned it. Make sure that North Carolina is one of the states that was proactive and has developed laws of their own. So make sure you have your North Carolina DOT aviation permit and you're very aware of not only FAA rules but also the additional North Carolina rules also.
All 5 are answered.
Yeah, and assuming that you've done the 107 remote pilot exam, become very familiar or intimate with aeronautical charts and using Google Earth. You will need to know where the airports are at. You will need to know where the VOR stations are at and where your research site is at, or your site is at, and if there's any military airspace nearby.
I'm going to say, just like I said before, just do your research on the systems. Don't go out and buy the first thing just because it looks great or you hear about it on the news that it's the latest, greatest. Sit down, do your research. Give any of us a call. Ask for the specific recommendations for people that have been flying. That's the biggest one. Is just you're going to get what you pay for. Don't rush out and be like, oh, it's the newest thing. Let me go buy it. Do some really detailed research on it.
I'm going to jump on that one then while Chris is handing it down. Expectation management, when we're working on our best practices from the university side, is always where we start with, because we get that phone call at least once a week of, yes, I'm ready to get into this. What should we go buy to get started? It comes back to, what are you trying to accomplish? And we've learned this the hard way of some systems are more capable than other systems. It's not necessarily based on cost. I think we've learned that the hard way. But it comes down to, are we trying to accomplish a survey mission? Are you looking at video? Are you looking at thermal? Are you trying to do ag missions? Are you going to fly frequently? All of that gets factored into making that decision. And so that's where we start with that expectation of, what are you trying to accomplish? What is your mission set before you even get going? So, Rick.
I would just like to add to what Chris said is do your research. And then once you get past the initial, what he went over is, think about residual cost and definitely training. You're going to get into things, spare parts, maintenance. You're going to get into software maintenance, updates, that type of thing. So just look at the residual costs. But I can't stress enough is really when you need to call an expert for training, get it, pay that up front, pay for it along the way. Don't try to learn this on your own. Call the experts and get properly trained.
Well, I'm going to go a different way, and this is as a service provider. I mean, right now we're still kind of in the wild west of this. There's a lot of, like Chris said, experts that aren't really experts. And so, I mean, we know that you need to hire someone who has a 107, and we know that you need to have insurance for the flight operations in case there's a system failure. But what's underlooked, as a service provider, is having professional liability insurance. So the flight is one part of it, and obviously you need protection for that. But you're creating information that's going to be used to make decisions, and those decisions, especially in survey, can be really expensive. Survey is generally the cheapest part of a project, but it's the foundation for everything that comes afterwards. So if the survey is wrong in the beginning and you do a big build project and it's wrong, the person doing the work is liable for that. And if they don't have the insurance, I mean, you can't, squeeze water from a stone. I mean, they need to have that. And a lot of people buying these services don't think about that portion of it. So I think if you're buying these services, you need to consider that portion of it.
That's a great point, Christian. One of the questions that comes up a lot on the data management, data privacy sides are, okay, if I'm a commercial operator, I'm a vendor now, I've got my commercial North Carolina permit, I've got my Part 107s, and a state agency wants to hire me, what do I need to think about? do I need the state agency, the government permit? No, you're still a commercial operator. You just need the government permit. But understand that any government requirements that they may have on them, they may pass down through their contract for data management, for privacy, for any of that kind of concerns. Commercial vendors that are offering agriculture services or some of those kinds of things. Again, the contract is going to define who gets to own that data at the end of it, how that data can be shared, how it has to be scrubbed on the backside. So that's where a lot of those questions come through. Of course, the lawyer was here for the last session, not here for this one, but he is prepared and able to help answer some of those questions too. So back to you guys. Anything else? Do we have recommended insurance companies for liability? So I'm pretty excited with our consortium at NC State. We have had an insurance company specifically building UAS insurance packages. Aviation Risk Management out of Greensboro is putting programs together, and so we've got. I was talking with him actually earlier this week, and so that's one that we're working with. AIG at the state level has a program too, and so yeah, we can definitely help out with that. Question in the back? No. Anything else? Go again.
One of y'all had tiles, ceramic tiles you were using. Yep. So without hole in the center, I assume you were just laying those tiles down.
For that, yeah, because we're on a beach on that application. So you notice we painted them so they're 4 triangles up to a conversion point.
Right.
And for that particular project, that's perfect. You can't get a hard point on the beach. So we need something we can measure.
Right.
Horizontally and vertically. And we use different things. We use Tyvek, big chevrons, but it's always something photo identified. We need to be able to measure X, Y, and Z of a location.
Like, do you have a specific size you like to use based upon an altitude?
Well, based on the ground sampling distance, yeah. So we want to be able to see so much. So those 1 foot by 1 foot tiles really minimum.
They were what, 1 by 1?
They were 1 foot by 1 foot. And those, for that particular ground sampling distance, that's about as small as you want to get. I wouldn't feel comfortable getting smaller than that. On some applications, we use Home Depot Hoover bucket lids.
Yeah.
They show up great in some of those areas, and you can put a cross, perfectly in the center of that circle. Sure. We put a nail through the middle of that and lay that down on the construction site. So there's just different things. I mean, it just comes down to being able to see it and measure that.
Right.
So the ground sampling distance.
1 foot by 1 foot.
Well, that was 1.2 inches. So yeah, I mean that was 1.2 inches for that particular. So it's about 10 pixels.
Yeah, what I recall correctly, the edge saw software said you had something like 15 pixels. We found that challenging because of quality.
Yeah, it depends on
That type of sensor, yeah. That type of thing. The edge saw, we did have moderate success with triple ZX5.
Right.
Just to give you a little bit more detail on the insurance stuff, right? AV risk. If you're starting out, as a new services or another company like that, you'll have to find out about getting workers' compensation or your professional liability, like Christian talked about. So I called around and I said, hey, I looked at State Farm and some of these others, and as soon as you mention a UAS, and they say, well, what is that? And you say drone, and they're like, nope, won't do it. AV Risk does do all of that, so we have all of our insurance through them.
What is it, AV Risk?
Yeah, it's Aviation Risk Consulting, AV Risk. That's the one that's part of the consortium. But so workers' comp, all of your professional liability, your general liability, they do the whole gamut of insurance products through that. Because it was one of those things that was, these different companies require that. Just give you an idea. You're looking into a bunch of different insurances for each application. So.
Yep. Good point. Any other questions? All right. Well, we're not letting you guys go. Gary, you got?
Well, just one of the things at Emergency Management that we're very for safety-wise that Kurt mentioned is air safety. And so during events, we want to make sure that the airspace is safe so that if we're flying our aircraft or someone else is flying, that we know who's flying. So if you're take part in an event, we need to make sure that's coordinated with the Emergency Operations Center and our air boss, or so that we know where you're flying and what you're flying, so that we will have safe airspace when we do that. That's not only for the UAVs, but also for our manned aircraft that are going in those areas. So air safety is critical, and so make sure you follow the procedures and make sure everyone's informed of where you're going to fly. And then you've got to also watch out for the hobbyists that will be flying in the area that we have to be concerned with also.
Go for it.
I live within 5 miles of an airport. Every time I fly, I have to call them. And every time I call them, I get a different person. And I get a different situation every time. Sometimes I've been told, no, I can't fly. And then I've said, I'm licensed at the FAA, I'm licensed in North Carolina. I talk them down from their panic, and then I can fly. Is there anything, I mean, do you guys go through that when you call and deal with towers? It seems like every time I call them, it's a different situation every time. I'm not confident in setting something up that I know I'm going to be able to fly. When I call them, it's like, oh yeah, I'm always nervous. I don't know what's going to happen.
It's been like that forever with the FAA. The flight safety offices regionally are working on better training. Headquarters is working on getting better training and information down to them, and then using them to help distribute that. I was talking at a conference last week with the FSDO office. He's working on a training program that he's going to pull us into to help with that piece of the information. But it has been such a moving target that they've struggled to keep up to. And so the best thing we can do is just keep building that relationship, just keep talking to them, and just keep them informed. Because like Gary said, that flight safety, airspace safety is the absolute critical piece to all this. And as more and more people are flying, we talked about it earlier too. Wayne actually shared a great statistic earlier that there's probably 100,000 drones in the air right now around the country. It's a 4-to-1 ratio of registered drones to manned aircraft already. And if you think about that there's about 250,000 manned aircraft that are registered with the FAA, well over 1 million already with the unmanned aircraft. That number is just going to continue to multiply. And so there's going to be those interactions. We've got to continue to make sure that we're doing things right. We are notifying, we're sharing the information, and we're continuing to put in place those structures. So the best thing I can tell you to do is just keep talking to them and develop that relationship. That's the way the FAA works. Chris?
Yeah, so we're doing some projects in Fayetteville, right? And so what we did was I requested a face-to-face meeting with Fayetteville, with Pope, and with Fort Bragg, with all their ATCs. And once you go in there and you start doing something like that, and they start to get to see your face and you start to show them your stats and everything else, you'll have a lot better result with that. On the FAA side of the house, I spoke to the FAA 2 weeks ago. I was on the phone 5 days straight with the FAA, and each day it was somebody different, and each day I was being told something different. And finally I said, I want your supervisor. And I explained to them this is what was going on, and then the following Monday I get a phone call, and it was an FAA supervisor, and he says, all right, wait a minute, so why do you have 22 airspace authorizations in for one location, for one ATC? I said, because that's what I was told last week. And he goes, that's stupid. So I have one authorization now that he did. He took all of that, combined it into one, and I have one Class Charlie airspace authorization. But I told him, I said, that you guys need, and Kyle and I, we've all talked about this, and we've told this to the FAA. They need to get some synergy in there, so everybody's kind of on the same page, because it is. But just stick with it. Just know that there's a lot of things from the top coming down on the high level side to where they are working on it. But I would suggest, as far as going to the airport and requesting a face-to-face meeting with them, show them your paperwork, and build that relationship, because it's all going to be building that relationship with them. So.
This will make you feel better, but we've been doing manned air photography for longer than the FAA has existed. And to this day, sometimes you get grounded or have to call tower for some unknown reason or misunderstanding by the FAA. So I'm sure that makes you feel better. No, actually, it makes me feel better. You guys share a similar
It's not just you. All right. Any final thoughts from the panel? Any last set of questions? Chris and Rick, Christian, are you going to be here tomorrow? So Gary, Kurt, either one of you guys going to be here tomorrow?
Yes, I have a session in the morning.
All right, so we got more of these guys will be around again tomorrow. So if you got any more questions that pop up overnight, they're here. I've got cards. I won't be here tomorrow, but we can make sure you get information if you need it. But thank you for the time, and we'll be here. Thank you.